Hello learners, in the previous session we start our discussion for motion in a straight line with the concept of point object, reference frame, position of an object. We talk about the distance and the displacement. Now let us continue our discussion by expressing the position time graph. By plotting the position time graph, we are going to discuss the motion that you have already studied in the 9th standard. So now let us see how to plot a position time graph with reference to the motion. Now the first case I consider is when the object is at rest. So how do we plot the graph? Along the x-axis we consider the time, and along the y-axis we plot the position. We plot the position, it can be in terms of meters, kilometers, whatever. Same way the time can be in terms of seconds, minutes or hour, whatever. Now when the object is at rest, so what is the pattern of the position time graph? Suppose we consider that initially the object is at a position of 40 meters from the origin. So here we mark 40 meters. We mark at 40 meters. Now with the span of time, since the body is at rest, it's not moving, so its position will not change, it remains same. So here you see the time is increasing. It's 0 seconds, then 10, 20, 30, 40 and so on, but still the position remains the same. So when we plot this graph, we get a straight line. So the graph is parallel to the time axis for the object at rest. So we can conclude that the position time graph is a straight line parallel to the time axis. Now look at the another situation when the object is in uniform motion. So first of all, let us recall that what is uniform motion. So for this again I consider a reference frame in straight line. Suppose this is the origin of this reference frame. This direction is positive, the other direction is negative. Now here suppose I consider an object travels this 40 meters in 1 minute, the another 40 meters also in 1 minute and so on. I mean to say that every 40 meters of distance is travelled in the same duration of time, that is 1 minute. Then such a motion is called uniform motion. So again I repeat, a uniform motion is the motion of an object in which the object travels in a straight line and its velocity remains constant. So when I say velocity, I mean to say its direction as well as its magnitude remains same along that line as it covers equal distances in equal interval of time. So this is a situation of uniform motion. Now let us see how do we plot the position time graph with reference to this situation. Yes, now again along the x-axis we consider the time, that is an independent factor, and along the y-axis we consider the position of the moving object. Now since the particle travels equal distance in equal interval of time, so we get the pattern like this. So it's a straight line inclined to time axis. So that is how we plot a position time graph for a body having uniform motion. Now let us consider another case where the object is having a non-uniform motion. So for that again I consider a similar reference frame, and now I consider that initially the body starts from 0 position and along the positive direction you see that division of the distance is given equal. So the span is 40 meters each, it's 40, 80, 120, 160 and so on. Now suppose an object travels first 40 meters in 1 minute, then another 40 meters in let's say 3 minutes, another 40 meters in let's say 5 minutes, and then another 40 meters, that is between 120 meters and 160 meters, it just travels in let's say 30 seconds. So such a motion is called non-uniform, wherein the distance travelled or the displacement is unequal in the same interval of time. And actually this is the only practical situation in our day-to-day life when we see the vehicles moving on the road. So when we drive the vehicle on the road, when we are like doing the journey, when we are traveling in any vehicle, then how do that vehicle travel? That travels with non-uniform motion. Why non-uniform motion? Because anyhow, sometimes the driver has to apply the brakes, sometimes it accelerates. So the motion is actually non-uniform motion. Now let us see graphically how can we plot it. So for this I consider a situation. Let us consider the motion of a car that starts from rest at time t is equal to 0 seconds. So here again you see that along the x-axis is the time axis, right, wherein we have taken the scale as in seconds of division of 2 seconds each. So 2, 4, 6, 8, 10 seconds and so on in the equal interval, and along the y-axis I have considered the position. So which starts with in meters, which is in meters, and the division is of 50 meters each. So herein we consider that initially the car starts from rest at, so initially the car is at this location from the origin and picks up speed till t is equal to 10 seconds. So by the time it's 10 seconds, here you can see it has picked up a speed till 10 seconds. So how can we find out that what is the speed? We can just drop the perpendicular with the scale, with a dotted line actually, and we can see that where this dotted line will be intersecting on this position axis, and that will be the particular distance, particular position after 10 seconds. So by the time it picks up, we see that we have got a curve. We have got a curve. Now curve in what sense? That if you see in the equal interval of time, if you will observe, you will see here that the speed is increasing or the velocity is increasing. Thereafter it moves with a uniform speed till 18 seconds. So from 10 till 18, if I drop a perpendicular, we see it is almost a straight line inclined to time axis, so which represents a uniform motion, and thereafter it applies a brake and the car stops at 20 seconds. So at 20 seconds the car stops. So again when the brakes are applied, again there is a curve you can see, but notice the pattern of the curve during the accelerating, when the car was speeding up and when the car was slowing down, that is a deceleration. So you can notice a pattern of the curve of this non-uniform motion. So now just see that at t is equal to 20 seconds, if we plot the perpendicular from the graph on the distance axis or the position axis, we get the position somewhat near about 300, and which is mentioned here as 296 meters. And this is how, using the position time graph, we can also find out the position of any moving object at any particular instant. Now again, just look at the entire pattern of the graph. So we can see it's a curve. So can we say it's an example of a non-uniform motion? Yes, of course. In the region from 0 to 10 seconds, we see a curve. In the region from 10 to 18 seconds, we see a straight line inclined to time axis. So this portion is of uniform motion. And again, between this 18 and 20 seconds, the speed is decreasing. It's a decrease in the acceleration value. So anyhow, the speed is decreasing. So finally, we see that this region is also representing non-uniform motion. Now, let us talk about the another important physical quantity which is used to describe motion, that is velocity. Now, we all know when the object is in motion, at every moment its position is different. If the displacement of any particle is more in the small duration of time, then its velocity will be large, but if the displacement is less, its velocity will be lesser, or in other words we can say it will be moving faster or slower, right? Now this velocity we describe in terms of average velocity. So how do we define the average velocity? It is defined as the change in the position or displacement. We all know this delta x, which represents the displacement, divided by the time interval delta t. So this delta t is a time interval in which the displacement occurs. We express mathematically this average velocity as V over a bar. This is a symbol for the average velocity, which can be expressed as x2 minus x1 over t2 minus t1. Now here, what is this x2, x1, t2 and t1? So in any motion, in any part of the motion, we consider t1 and t2 are the times, are the instants, and x1 and x2 are their positions respectively at those times. So that we can say x2 minus x1 is delta x, which is marked here as displacement, and t2 minus t1 is the time interval delta t. So that is how we express average velocity mathematically. Now let's come to the SI unit of velocity or average velocity. What will be its SI unit? So by the formula itself we can see, since it is displacement upon time, so its SI unit will be meters per second. Its SI unit will be meter per second. We can also write down it as meter second to the power minus 1. So these are the two ways of expressing the average velocity or the velocity. But in our day-to-day life, in everyday life, when we generally talk about the motion and the velocity, we talk about the velocity of the vehicles. So generally we express it in terms of kilometers per hour. As you all know, we express the velocity of a car or the velocity of a bus. This bus is moving with a velocity of, let's say, 50 kilometers per hour. So this is how we represent the average velocity. Now let us consider an example. A passenger inside a moving train took 5 seconds to move minus 4 meters. The negative sign here indicates the displacement is opposite to the position of the engine. And then how to find out his average velocity? So he took 5 seconds. So here time is given 5 seconds. And he moves minus 4 meters. So what is this minus 4 meter? It is a displacement. So I can say this is a time interval delta t, and delta x, which is the displacement, is minus 4 meters. Now what is this minus sign indicating here? As mentioned here, it indicates that the displacement is opposite to the engine. I mean to say that let's say this is a compartment of the train, and suppose this is a person, right? And suppose the train is moving in this direction. We are assuming that the engine is this side. This side is the engine. So the train is moving in this direction, and then the passenger is moving inside the compartment opposite to the direction of it. So that is the significance of this minus sign here, right? Now then what will be the average velocity in this case? Again, we know average velocity, it is delta x over delta t. Substituting the values, we get minus 4 by 5, and when you solve it, you will get minus 0.8, and since the distance is in meters, time is in seconds, the unit will be meter per second. So this will be the average velocity of the passenger which is moving inside the train. Now we see here that average velocity can also be negative. Again, it's a vector quantity. So just like displacement, as displacement can be positive, negative, 0, same way the average velocity can also be negative, positive and 0. So it has both magnitude and direction. Now let us take one more example. Consider the motion of the car as shown in the graph. So let's say this is a graph which is representing the motion of a car, and by the pattern itself we can analyze that it's a non-uniform motion. Anyhow, as seen from the plot, find the average velocity of the car between 5 seconds to 7 seconds. This is what we need to find out using this graph. Now again, along the x-axis we see the time, along the y-axis is the position of the moving car, but we need to find out the velocity only during the duration of 5 to 7 seconds. So just locate your pointer at this 5 seconds and drop the perpendicular on the graph with a dotted line. Same thing you have to do at 7 seconds, just drop the perpendicular till the graph, and at those point of intersection, this is a point of intersection and this is a point of intersection, We drop the perpendiculars, which is shown here by the solid black lines, you can see. We drop the perpendicular on the position axis, and these intersecting points gives us the corresponding positions of the car at the two instances. Now here, I consider this as time t1 and this as time t2. I mean to say 5 seconds at time t1, 7 seconds is time t2. So the corresponding position is here, we can see x1 is 10 meters and x2 is marked here as 27.4 meters. So this is actually x2. So how do we find out the average velocity? Again with the same formula, average velocity is equal to delta x over delta t, wherein how much will be delta x? Delta x will be equal to 27.4, it is x2 minus x1, so 27.4 minus 10 upon 7 minus 5. So when you solve it, you get it equal to 17.4 upon 2, and this will be equal to plus 8.7 meter per second. So this gives us the value of the average velocity between this duration, right? So that is how we see the two examples. In the previous example, we have come out with the negative velocity. In this example, we have come out with a positive velocity. So we have seen the two cases wherein in one case the velocity was positive, in the other case the velocity was negative, and same way if the displacement is 0, then the average velocity will also be 0. So can we think of any case for the 0 velocity? Yes, of course. Suppose I consider that this is the starting point of an object, let's say point A, or you can assume that this is your home and then your school is at point B, which is let's say at 3 kilometers, and then when you cover the round trip, then the average velocity will be 0 at whatever velocity you were moving at some instances, but still the average velocity will come out to be 0 in one round trip. I hope I am clear with this point. Now let us analyze about velocity using the position time graph. Let's see what information we can draw from position time graph with respect to this velocity. Now here you can see a plot. It's an xt graph which shows a straight line inclined to time axis, and we all know that it represents a uniform motion. Now this xt graph for an object is moving with dash velocity. So what should be filled here? The xt graph of an object moving with, is it a positive velocity or a negative velocity? So we see here that with time the position is increasing in the positive direction, so the object is moving with the positive velocity here. It is moving with the positive velocity. Now let's take the another case. Here is again an xt graph. It's again representing uniform motion, right? Because it's a straight line inclined to time axis. But now here what do you see? With the increase in the time, the position is moving towards the origin, that is in the negative direction. It is directed towards the negative direction. So this xt graph is representing a negative velocity, right? Now look at the another situation. Here the xt graph of an object, what does it represent? It represents the body at rest. So it's moving with 0 velocity. So this information we can obtain from xt graph about velocity, whether the velocity is positive, negative or 0. But in all this discussion, we have seen that the velocity depends on the displacement. Both are the vector quantities. They just depends on the final and the initial position of the particle. It has nothing to do with the entire journey, that what was the velocity during the entire path, like you have traveled from home till your school, and then you return back to home. So you travel the distance also, you travel the path length also, time was also involved. So but still the velocity is 0, the displacement is 0. So at times it is not of much use. In that case, when we actually want to know about the speed, we talk about another physical quantity called the speed, which gives us the information about the actual motion, which depends on the actual length of the path travel in the given interval of time. So for that, we talk about another physical quantity, average speed. So how do we define the average speed? It is defined as a total path length traveled divided by the total time interval during which the motion has taken place. So mathematically, we can write down the formula of average speed as average speed is equal to total path length upon total time interval. Now let us consider an example to get a better idea of speed. According to this example, a train travels from station A to station B and back in 1 hour and 40 minutes. So let's say this is station A and this is station B. So the train, it travels from A to B and then returns back. This is what is given. And the total time taken is 1 hour and 40 minutes. Right? The distance between the two stations is 35 kilometers. So what is the distance between them? The distance between them is 35 kilometers. Now, we need to find out the average velocity and the average speed of the train in meter per second. So here, if you look at the units, the time is given in hours, minute, the distance is given in kilometers. So first of all, we'll convert time and distance in seconds and meters. So how to convert this time? What we are going to do this? So so the time will be actually 1 hour ko, when we convert it into seconds, we get 3600 seconds plus 40 minutes ko need to convert, we get 40 into 60 seconds. So that we get the total time as 3600 seconds plus 2400 seconds. This will be the total time. So adding up, we get time is equal to, we'll get it equal to 6000 seconds. This is the total time taken, right? Now, let's convert this kilometers also in meters, so that the distance will be equal to 35 into 1000 meters. So finally, it is 35,000 meters. Now, let's calculate first of all average velocity. So what is the average velocity? Average velocity is, we know, is delta x upon delta t. What is the total displacement in this case? Since the train travels from A to B and then returns back. So the displacement is 0. So the average velocity is 0. Right? Now, when we talk about average speed, so for that, what we are going to consider? Let's find out average speed now. So the total time taken is 6000 seconds. The distance is 35,000 in one trip, that is going from A to B. But while coming back, so the total distance travel will be 2D now. So now the speed, the average speed will be equal to total distance upon total time. Total distance, that is the total length of the path, upon total time taken. This is how we will get the average speed. Now substituting the values, the total distance will be now 35,000 multiplied by 2. So anyhow, or we can add up it. So we'll get it equal to 70,000. And the time duration is 6,000. Now, when we divide it, 70 by 6, we will obtain the value as 11.6 meter per second square. So now here we obtain the average speed as 11.6 meter per second is the average speed. Similarly, we can just compare now. The average velocity of the same motion is 0, but the average speed has come to be 11.6 meter per second. So this is the difference between the average speed and average velocity. Now let us recall what we have learned today. We have learned that the position time graph is a straight line parallel to time axis for a body at rest. If the object is moving along the straight line, covers equal distances in equal interval of time, it is said to be in uniform motion along a straight line. We studied about the average velocity, which is defined as the change in position or displacement divided by time interval. The average velocity can be positive or negative depending upon the sign of the displacement. It is 0 if the displacement is 0. Then we talk about the average speed, which is defined as the total path length travelled divided by the total time interval during which the motion has taken place. So this is all about this session today. Now we'll continue with the chapter in the next session.